Nature is a puzzle, right? And we need to understand this puzzle in the simplest possible way. Einstein said the laws of nature should be made as simple as possible, but not simpler. You know, it should be easy to understand, but not so easy that it's not true. You know, it can't be a myth. It can't be a story that we tell children. It has to be something that is verified through experiment. And the way the science works is that if one experiment, one single experiment, contradicts a theory, the whole theory collapses. I'll give you an example. Isaac Newton came with the idea of laws, universal laws that explain gravity as a force that attracts body instantaneously in space. And there is a mathematical formula for that force of gravity, right? A universal law of gravity. It works wonderfully. It explains and allows us to predict the motion of the planets, the movement of the moon around the earth, the falling of apples from trees. Everything we do in mechanics is explained through laws that were written in the 1600s by Isaac Newton. But there was a single planet that did not obey that law, Mercury. Mercury, we could not predict where it will appear according to the laws of Newton. That was one problem. And there were many questions also that we could not answer applying Newton's laws of motion. For example, we could not answer how the force of gravity is actually happening. How is it transmitting that force through space? How is gravity working? A lot of questions that Newton did not answer and could not answer and remained unanswered until Albert Einstein came with a different approach. In fact, he suggested a different paradigm, a different model in which time is not universal, time is not absolute, time depends on who is standing where. So if I am traveling on a spaceship away from the Earth at a very high speed and I come back to the Earth, I might be younger than you. And this is something that has been totally proven through experiments. And the positions of Mercury around the sun could be much better predicted, exactly predicted, using relativity. So relativity was an improved theory for the nature of these forces. Einstein suggested that instead of thinking of forces that act instantly in space, we have to think of space-time itself curving around objects. And that meant that light itself would curve around an object. So that meant that light did not travel in straight lines. So if we could prove him wrong, because this is the way, you'll see this in TOK, no? It's called, when we want to prove something wrong, we call it falsification. So in science, we're not trying to prove, we're trying to disprove, right? Even our own ideas, we're trying to make sure they're wrong. And if we can't make sure they're wrong, then the theory remains. But it is always contrasted with evidence. So we're looking for anomalies in experiments. Yeah, that's the way science works, right? So Albert Einstein suggested light curves around objects, and they said, you're crazy, and of course he wasn't, right? 140 scientists signed a book saying, because he was also a Jew during the war, so it wasn't the people that they wanted to, German scientists would not agree with him. And he said, you know, if I'm wrong, we don't need 140 scientists, we only need one. But he has to prove me wrong. And to prove me wrong, you have to take a picture of a star during a total solar eclipse, and you'll see if the star moves, that means if the light coming from the star curves around the sun, because the sun doesn't allow us to see the stars, but if there is an eclipse, we can see the sky during the day. And if we see the star moving, it's not in the place that we know it is, but it seems to be in another place, that is because light is bending around the sun when it comes to the Earth. And that experiment was performed by Sir Arthur Eddington. It was a very difficult experiment because it was during the war. They had to go to Germany, Russia, because it wasn't an eclipse that would happen anywhere in the world. And actually, he was proven right. And he was never awarded the Nobel Prize of Physics for relativity, you know. He was awarded the Nobel Prize of Physics for the photoelectric effect. the start of quantum physics also came from in Einstein's head, you know. And so this is the method of science, right? This is what science is about, right? So it's a puzzle. How? I'm gonna give you a very simple way to look at nature as a puzzle, and this is going to be an approach for meditation. I don't know if you, yes.
Oh, I'm sorry to interrupt, but what causes light to curve?
The gravity. I mean, light follows space-time. Light travels in space-time, right? There is no space without time, space-time. So if space-time curves, and space-time curves because you have to think of the universe as an elastic sheet that is curved when you have a body of mass, right? So for instance, a star will create curvature in space-time. And light can only follow space. So why does the Earth orbit around the sun? It's not because there is a force of attraction according to Newton's law. It is because it can't do anything else, because the Earth is following the curvature of space-time. So if you are traveling through space and there is a body like a planet or a star, space curves towards that planet, so the body has to fall in space. Do you know where the word measurement comes from? Measure?
Latin?
No. Older than Latin.
Greek?
Older than Greek.
Sanskrit?
Sanskrit. It comes from Maya. 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 You know what Maya is? Illusion. Maya means everything we can measure. And everything we can measure, according to the ancient rishis in India, is an illusion. So this is in the core of the philosophy, the Vedanta philosophy. What we call reality is an illusion. And what physics is all about is about understanding that illusion. And to understand that illusion, we measure. Now, when we measure, we can never measure anything exactly. There is always some uncertainty, because if we use a ruler that has millimeters, we are measuring something to an accuracy of uncertainty of 1 millimeter, right? If we measure time to the 10th of a second, that is the limitation to the instrument is limited, right? So the first thing we have to know in physics is that physics is never exact, because measurements are never exact. What is your exact height? You can't tell me, right? You can't tell me, because I would say, oh, no, I want to go up to the microns. No, I want to go up to the 10 to the minus 17 meters. You know, it's impossible to measure anything exactly. So that is one thing. That's why physics is not an exact science, it's a natural science. And the first unit is about measurement and uncertainties. There is a principle in physics that is called the principle of uncertainty. Heisenberg realized that when you try to look at something, you're affecting the experiment. When you observe something, the act of observing affects the system. In the microscopic world, when you observe an electron, you need to throw light at the electron. So if you want to see something tiny like an electron, you need light. And the act of hitting the electron with light changes the momentum or the position of the electron. So it is impossible to know exactly anything. And that is a principle of uncertainty. Physics is built about principles. So the first thing, like maths, is built on axioms. Physics is built on principles. So the difference with math is that in math we start from axioms. In physics we end up with principles. You know? We end up saying, okay, this is how far we can go. There is a limit to what we can measure. There is a limit to what we can know. And that is a change in paradigm for science. All right, so this is my puzzle here. Hola, Elizabeth. Okay. So we have 5 elements in nature, Mahabhutas, the 5 elements from Tibetan or from Vedic knowledge, you know, Vedanta philosophy. 5 elements in any culture. Anyone coming from China, even from America, you know, the Indians in America, they conceived the world with 5 elements, obviously. Some 4, some did not consider space. But we've always seen the earth, the air, the fire, the water as elements in nature, right? So you have to just imagine imagine you're sitting, like you're now sitting on earth, and just observe, there is earth underneath, there is water. Water is everywhere, it's in the air, it's humidity, but it's also in the oceans around the earth, right? Most of the planet is water, most of your body is water. There is heat, fire, yeah, the sun, it's a sunset, air, and then space. 5 elements in nature. Inside your body, you have the same elements. These are called chakras. There are 7 main chakras in the body, energy centers. One is in the base of the spine and is connected to the element earth. It's called the Muladhara chakra, you know? There is another one that is behind the genitals, connected to the element water. Another one that is here in the solar plexus, connected to the element fire. It's where the digestive system is. Another one that is here in the center of the chest, connected to the element air, where the lungs are, right? Where the heart is. It's an energy center in the body, air. And then another one here, where the neck, the Vishuddha chakra. This chakra is connected to the space element. And then there is another chakra in the center of the head, the third eye, and another chakra above the head, 1 foot above the head, where the tip of the crown is. And that is the limit to the, not the physical body, but the subtle body. There is a body of energy. You know, it's called an aura, a field of energy. You know, that's what we are. We are a body-mind system, and the mind is bigger than the body. All right? So it's the macrocosmos and the microcosmos is made of 5 elements. A very simple idea, right? And now I'm going to go in 10 minutes through all the topics that you have studied last year, right? Very, very quickly. I will get these cards and I will say, and this is, again, this is not something that I created or invented. This is something that I understood and learned from Vedic knowledge. This was written in the Ashtavakra Gita 5,000 years ago. So there are 5 systems to perceive the energy from nature, 5 systems of perception, 5 senses of perception, right? Very easy. We have to think about connections between the senses of perception and the elements of nature. So let's look at the eyes. The eye. B6, right? We studied this in IGCSE. What does the eye perceive? What goes into the eye?
Light.
Where does the light come from? The sun, right? So does it make sense to say that the element fire and the eyes are connected? The sun, the light. Does it make sense? Yeah, do you agree with that? Good.
Wait, won't sun come under space?
Sun is fire, it's a source of light.
So
Space is space. I mean, the sun is a star. So it's the source of light and heat and energy. And what we perceive with our eyes is light. Yeah? So you don't see matter, you see light. Okay. The sense of touch, the skin. Where would you put the skin? B6. Remember what the skin does, right? The skin is responsible for keeping the body temperature. Homeostasis. You remember that? The function of the skin is to, first of all, it's the largest organ in the body, and the function is to keep the temperature of the body constant, so it releases heat to the air, you know, or it takes heat from the air in. Like that connection from inside to outside has to do with touch. Where would you put it?
Air.
Air. Who said it? Good. So, I mean, you can disagree with this. I don't mind. We can discuss it. But let's play with the puzzle. Let's see if it makes sense. Air. You could say, no, air has to do with smelling. But you know what? Smell. The air doesn't smell. What smells is the flowers, the organic matter. The earth is the element that is connected to the sense of smell. Yeah, nitrogen, it has no smell. Hydrogen, oxygen, no smell. But something that is in the earth, like the earth getting wet, you can smell it. You can smell the flowers, you can smell an apple, you can smell a fruit, right? So the sense of smell connects to the element earth. Yeah. And then we have taste. Where would you put taste? You have to choose between water or space. It makes sense? Salivary glands, water. Remember that what you eat is water. So we have the sense of hearing with the akasha, with the space. Just for you to think about it. Our ears connect with the waves that travel through space. I know they create vibrations in the air, but inside the drums of the ears, what goes into your head is an electromagnetic wave, right? So 5 systems of perception, 5 elements of nature, done. So we are a system that is absorbing energy in the form of sound, light, food, and air. I said last class, 10,000 liters of air a day, right? And with that energy that comes into our body, we work, we do actions. And they said that there are 5 possible actions. Human beings can only do 5 things, no more than 5. And if you discover which one is your talent, what are you good at, you can very easily start thinking about your future, because you discover that you are good at doing some of the possible actions that we are able to do, and then you'll say, okay, so if this is my talent, I will explore it. So what are the human actions? Let's see.
You can think.
Think, that's the first one. Where would you put the action of thinking? In what element?
Space.
Yeah, why?
Because space, there's. No, I just related it to one.
Yeah, the head thinks. The head thinks, and in the head, the neurons are floating in space. The neurons in this brain, like every cell in the body, but the nervous system is electromagnetic waves that travel through space, right? It's electricity. Good. So we think. What else? Just for you to know, 25% of the energy that comes into your body is used for thinking. So if you want to lose weight, study. Yeah.
Oh, you can move.
Move. What do we use for motion? Legs. Where would you put that action? Amara? No. Yeah, Amara. No? No. Amara, sun.
Yeah.
Sun. Earth. Because we move with the legs on the earth. Simple, no? Simple. What else can we do?
Make.
Mate. Man, you're amazing. The action of reproduction. Where would you put that?
I'm not sure.
Oh, come on, you know it. Don't try to be shy.
Fire.
Yeah, sure, fire. Sex. What? Fire. The fire of life, reproduction. If you don't have that fire, you won't have babies.
I'm not sure about this, but like speaking.
Yeah, the tongue. It's an organ of action. Talking. Where would you put talking?
Air.
Yeah.
Air? Why?
It's like when you speak, it's just basically like expulsion of air.
Perfect, perfect. You're making the air vibrate, right? That's what's happening now. I am putting energy in my body to create vibrations in the air. And if you think about this, those vibrations in the air reach your drums. They become electromagnetic waves in the space inside your brain. And everything that I'm saying makes sense. And you're all understanding everything I'm saying. Just that is a wow. Like this is a pool of air, and what I'm doing is this. And you're understanding what I'm saying. Yeah? Isn't it wow? Yeah, it is, no? What else can we do?
Soon.
Input of food is not work.
No.
I won't pay you to eat. It's input, it's energy. What else can you do that I'll pay you? Work is something, yes.
Farming.
farming, how do you farm?
Using your
Using your legs and what else?
hands.
Your hands. What else can you do with your hands?
Feel.
Work with your hands. You can play the guitar. You can become a warrior, a soldier. You know, you can become a painter, a writer. All these actions that are very fluid. The most fluid organ or system of actions is the hand. You can talk with your hands, right? You can express yourself. You can kill with your hands. You can heal with your hands. So the hands go here. And if you try to find, and this is a challenge for you, if you find an action that is not one of these or a combination of these, I'll pay you $1 million, right? I promise. I've been doing this for years and nobody came with any action. Action means output of energy, right? So you can go home and think about it and come, and then you come and say, I got it. And you see it's wrong. All right. So, motion we studied in physics last year. Well, we'll see everything. We studied a little bit about the reproductory system, no? The sexual systems or whatever you call it. A little bit about the nervous system, the brain. So let's look at systems inside the body-mind. Is systems inside the body, microsystems, systems that are inside the body that connect to nature. Yes. No, yeah, you.
Okay, so I would say like your muscles.
Muscles, where would you put them?
I'm not sure.
Where would you put the muscles, the bones, the structure of the body? What? Earth. It allows the motion, right? No muscles, no motion. So muscular system, skeleton, if you studied that. What other system?
Like circulatory.
Circulatory system there, right? Where would you put it? Water, by all means, water, 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 look. There you go. It's 98% water. The plasma that moves in the body is water, right? Let me see somebody. Okay, I like Rehan.
Digestive system.
Where would you put it?
Fire.
Fire. So this is B3. Fire, B3. Everything we studied last year in biology, right? Respiratory system. Air. And what would you put here? Nervous system. So this is B6 also. So this we studied last year. I'm putting the syllabus of science in one matrix, right? Okay. Next. Systems that are outside of us, all around us, cycles. Cycles in nature. So, for example, photosynthesis. This is a cycle of light in nature, right? It's the transformation of light into matter. What happens between the plants, the sun, and the earth, right? Where would you put that? Fire. You studied photosynthesis last year, right? So let's put it here in fire. Well, obviously, the water cycle, no? In the water element. This is the carbon cycle. Where would you put the carbon cycle? It's mainly in the earth, right? Most of the carbon goes to the earth. I know that some carbon is trapped in the air, and we discussed about bringing it back to the earth. But carbon cycle, we can relate it very easily to the earth. What cycle would you relate with the air? The air is mainly 70% what? Nitrogen. So the nitrogen that flows in nature comes from the air, right? So the nitrogen cycle, you studied this, right? BE4. And the universe, the biggest cycle of nature, you have not studied yet, because IGCSE sucks. We didn't study a lot of astrophysics. But the universe is the biggest of all systems, right? So I'll put it in space. Does that make sense?
Yeah.
It's a simple puzzle. Now we go into physics. Physics has different fields, right? So let's talk about the different fields in physics. For example, we're going to start learning about forces, bodies, motion, what we call mechanics, right? Mechanics is topic 2. Topic 2 is a big topic in physics. Where would you put this? Earth. Right, because it's about the motion of bodies on Earth, right?
Thermodynamics.
Thermodynamics, the study of heat, fire. Light also, light and heat. The study of light and the study of heat, we're going to look at that. Yes?
Astrophysics would be space.
Astrophysics would be space. You know, astrophysics, nuclear physics, quantum physics, electromagnetism, a lot of different fields in physics in space, right? Electromagnetism happens in space also, yes.
Like gases.
Gases, the study of the gases, this is topic 3. And hydraulics, using water to create transformations of energy, right? Hydraulic machines, like the transformers. Yes, Justin. No? You just stretching. All right, so this is the big picture of physics, right? It has rows and it has columns, right? And this is a lot of biology and some physics here, right? But this is nature. We're going to focus on physics. We're going to drop the biology for some time, but you will see that everything we learn, even if you decide to become a molecular biologist next year, you will need to know physics. Physics, as I said, has a big range of topics. So this matrix is something that I want you to bear in mind, keep in your memory. I am sharing this video with you, and I also created a video on YouTube explaining this matrix 1, I call it, which is the big picture of physics or science. Yeah, got it?